Hello friends, this video on probability part 3 is brought to you by examfear.com. No more fear from exam. Before watching this video, you should have watched video probability part 1 and part 2. Let's take an example of mutually exclusive and exhaustive event. Two events or three events which are exclusive. That is, their occurrence are totally independent, but when you club all those, you get the whole sample space. That is exhaustive. So exclusive means, I'll write term here, independent, and exhaustive mean total sample space. Let's see this. A coin is tossed 3 times. Consider the following events. A, no head appear. B, exactly 1 head appear. And C, at least 2 head appears. So coin is tossed 3 times. Do they form a set of mutually exclusive and exhaustive events? That's the question. We'll see A. In A there is no head. So A will have this, no head. B, exactly 1 head will appear. So we can have head like this, or we can say tail head tail, or we can say head tail, tail tail head, or tail tail. So there can be 3 possible scenarios because there is only 1 head. And C, at least 2 head, 2 or more than 2. Let's suppose 2 head, then we can say this, or we can say this, or we can say this. But say 2 or more. When you add more is, it can be 3 head. So A is no head, B is exactly 1 head if you see, and C is 2 or more than 2 heads. Now the question is, do they form mutually exclusive event? If you add all this thing, what you get is this. Now the sample space when you are throwing a 3 die is, so let's suppose you got head first and tail next, and then you get head, and then you get head tail, and you get head, and you get tail. Now with this, again, 2 more possibility. So with this you get head, or I'll write here head, head, tail. With this you get head, or you get tail. With this you get head, or you get tail. With this you get tail, or you get. So there are 8 possible scenarios. Now let's see if everything is covered. TTH, TTT, HTT, HTT, THT, THT and THT, TTH, TTH, HHT, HHT, head tail head, head tail head, tail head head, tail head head, all heads. So if you see, when you combine these, we get the sample space. That means all these are exhaustive events. Also you see, right, there is no overlap. So these are not overlapping. So these are mutually exclusive also. These are exhaustive because when you add all this thing you get sample space. These are mutually exclusive because they are not overlapping. They are not overlapping each other. There is no common element in A, B and C. So when you draw a diagram for A, B and C, you will get something like this. This is A, this is B, this is C. This is how we will get A, B and C. You will notice that they are not overlapping. So they are mutually exclusive and exhaustive events. Hope this clears it out. Now we will study axiomatic approach to probability. There are various formulas here which you have to learn. Axiomatic approach is just another way of describing probability. Here axioms are used. Axioms are nothing but rules. In this case we have to assume something. For example, let S be the sample space of a random experiment, and there are various outcomes. Outcome 1, 2, outcome 3. Outcome 1, outcome 2, outcome 3. Then probability of any outcome is greater than or equal to 0. We know that either it will not happen or it will happen. If it will happen, it will be greater than 0. Also we know that probability of sample space, that is the whole thing, is 1. because probability is nothing but the favorable event by total event. if favorable event becomes total event, probability is equal to favorable by total. If f is equal to t, if you are saying f is equal to t by t, that's equal to 1. So maximum value of p can be 1. That means we can say that probability of any event or any outcome is greater than 0, greater than equal to 0, less than equal to 1. Also, when we add all the outcomes of a probability, you get 1. Also, PE. Let's suppose in any event E, for example, when we have taken a die thrown and we're getting 1, 3, 5, which is an odd event, right? So P of this, let's suppose this is E. So P of E is equal to actually P of 1 plus P of 3 plus P of 5. This is how the convention. P of E is equal to sum of all the elements in the B. You see, P of E is equal to sum of P Wi, where Wi is a member of E. And P of phi is 0. If there is no occurrence, then it is 0. These are the common conventions which we use. Please note this. I'll reiterate once again. Probability of any outcome is greater than or equal to 0 and less than or equal to 1. If you add the probability of all the outcomes, you get 1. And for any event P which has some outcomes, probability of that event is equal to sum of outcomes in that event. And probability of phi is 0. Now let's see if this satisfies axiomatic approach. So we have a space where we have this outcome. So outcome 1 is 1 by 6, 1 by 2, 1 by 3, 1 by 6, 1 by 6, 1 by 6. Outcome 1, 2, 3, 4, 5, 6. So in case 1, let's take case 1 here first. Outcome 1 is 1 by 6, 2 is this. So we have seen in the last example that sum of all the probabilities 1. This is 1. So let's add this. So when we add this 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6, what we get is 6 by 6 is equal to 1. Also, all the probabilities which we see here is greater than 0 and less than equal to 1. There are two conditions you have to check. One is sigma p is equal to 1 and p is greater than equal to 1. So in this case, both the conditions are satisfying. That means we can say yes, this is a axiomatic approach. It satisfies axiomatic approach. In second case also, when you see sum is 1 and all the p is either greater than equal to 0 or less than 1, so we can say yes. In third case, we can see some of the probability are negative, which is not possible. It should be greater than 0 less than 1. So this is not axiomatic approach. In this case, if you observe clearly, this is 3 by 2. 3 by 2 is 1.5, which is not satisfying this condition. So this is not the axiomatic approach. In this case, all this is satisfying this. Now let's add this. When you add this, 0.6 plus 0.5, 1.1, 1.4, 1.5, 1.8, 2, it's 2.1. 2.1 is, it should be equal to 1 because sigma p is equal to 1. So it's not 1, so this is also. To reiterate, sum of probability should be equal to 1 and all the individual probabilities should be greater than equal to 0 and less than equal to 1. First condition satisfies both, so it follows axiomatic approach. Second also satisfies. Third, fourth and fifth doesn't satisfy. Thank you. Visit examfear.com to watch free educational videos, try free online test, get the best quality study material, study from the best tutor and mentors, and much more. Thanks once again.